Good afternoon, dear ecologists. Let me present a report on the topic Effect of Recreation on the Spatial Variation of Soil Physical Properties. Introduction. Park plantations are an important component of the urban environment that perform a wide range of critical ecological functions. A scientific number of these functions are related to the condition of the soil cover of park. The recreational loads strongly affect the soil. Understanding the effect of human-included disbalance on ecosystem process is important for recreational area management. Human trampling of the soil causes most of the impact that reaction has on soil and vegetation. All soil components, mineral matter, air, water, dead organic matter, and living organisms are disbalanced by trampling. Leaf litter biomass decreases and soil density increases with trampling intensity. When trampling components the mineral soil, which doesn't have the physical elasticity of organic matter, the bodies are pressed together, dramatically reduce the number of proper between the parties. The soil penetration resistant, along with other morphological and physical properties, is used to diagnose urban soil and is a reliable indicator of recreation load. The soil components increase the resistance of the soil to plant growth and impediment the movement of soil animals, reduce porosity, which slow water transfer and air diffusion, and decrease the rate of mineralization of natures. Research aim and objective. The aim of our study is to test hypothesis that the recreation load causes the formation of spatial patterns of soil preparation, which by the excellent rate exceed the zone of direct influence. Material and methods. The study of influence of recreation load in the physical preparation of soil was carried out in Novoalexeyevsky Park, Melitopol, Ukraine. 2 polygons were set up. The soil penetration resistant and soil moisture measurements were carried out in polygon number 1 in October 2020 and in April 2021. The measurement in polygon number 2 were taken in April 2020. Each polygon contains of a network of 105 sampling points located along 7 translate with 15 sampling points each. A handheld penetrometer was used to measure the soil penetration resist to a depth of 100 cm and 5 cm universal, a total of 20 measurements of each point. The soil penetration resistance was measured in the file each camp measured penetrometer to a depth of 100 cm and 5 cm universal. Measurements were made with a cone with a cross section of 1 square centimeter. At each measurement point, the soil penetration resist was performed in only one replication. The local of trees within the polygon in the 3 meters vicinity was always mapped. Based on the result, geographical information about the date was created in the software ArcGIS ESRI. Describe scientists have been calculated in the software Statistica. Starts off. Results. The polygon 1 and 2 different in the level of recreation load, which was characterized by the distance from the spooned-out walkways. The distance from the pathways within the polygon 1 was 3.1 plus minus 0.24 meters. Maximum distance was 9.4 meters. The distance from the pathways within the polygon 2 was 4.1 plus minus 0.32 meters. Maximum distance was 14.9 meters. The difference was statistically significant. T-value was 3.08 p. It's 0.002. Tables 1, 2, and 3 show statistical indication of variability of soil moisture and penetration at different depths within polygons 1 and 2. Thus, an increase in the soil penetration resistance in vice was observed both near the recreation paths and a considerable distance from them. A minimum value of the soil penetration resistance was observed at a distance of 3-5 meters from the recreation path. A similar pattern was observed with the regular of the effect of distance from trees on the soil penetration resistance. The soil penetration resistance was greatest near the tree and at a considerable distance from the trees. Discussion. Soil penetration resistance measure with a cone penetrometer is an important parameter in many soil management studies. The level of soil penetration resistance depends on many factors. The penetration resistance is a physical property of soil that depends on soil texture. The regression coefficient obtained from the GLM analysis the dependence of soil penetration resistance on soil moisture and the distance from the regression paths and trees are given in the table. Soil penetration resistance is highly developed on soil type and soil properties such as volumetric water content, soilmatic potential, dark density, porosity, and organic matter content. The temporal and stepping dynamic of the soil moisture content are signified for that affect this indicator. The difference in soil moisture can also be included by the recreation load. An increase in recreation load leads to an increase in the soil compactness and concreteness of which may be a reduction in the volume of the soil pore space and thus a reduction in the volume available for the stores of water. Also, an increase of compactness leads to an increase in the proportion of small pores, which increase the intensity of capillary upfeed of the water and thus contribute of increase in the rate of every point of water from the soil surface. The regression can have not only a direct effect on soil moisture variation, but also an indirect one. The systematically movement a large number of people leads to an increase in the soil compaction, which is reflected in the soil penetration resistance. Evidence was obtained which indicated that human trampoline has the greatest effect on overall property and soil penetration resistance. Our results suggest that the confidence effect is observed over a much larger spatial range than the visible boundaries of trails. This effect is largely refused in the confidence of the soft soil layer, but the soil penetration assessment of the soil is also sensitive to this compaction of the entire measured deep range. Tree stands in the riparian mixed forest are significant factors to stretching both the hierarchical community and spiral variances of soil physical properties. The soil near the tree trunk has great penetration resistance. The ocular movement of the crowd under the action of vital energy are transmitted through the trunk to the soil. The vibration energy is transmitted to the soil and is spent on its component, which make the soil near the trunk more compact. The tree also activates development moisture, so the soil penetration resistance can be higher in the vicinity of the tree trunk. The effect of trees on the soil components extremely over a distance of up to 8 meters. Conclusion. The fragments of trees form patterns that are similar to the mechanism of variable in-soil penetration resistance in natural conditions. The influence of spontaneous passive waves on the spatial hierarchy of soil property is commensurate with the natural variable in magnitude. The superstition of these two sorts of variation in the soil property creates a mosaic of parkland soil cover. The effect of recreation passive waves has considerable span extent, both horizontally and vertically. The models of the effect extend considerably beyond the visible boundaries of the passive waves. The various of soil properties affects the redistribution of soil moisture and the soil air, which significantly affect the living condition of soil biota. The finding point to the need for recreation space management to minimize the negative effect of spontaneous pests, the role of which has ability been previously underestimated.